Welcome to SAP 2000, a comprehensive, yet easy to use, state-of-the-art finite element analysis and design package. In this tutorial, we will create a simple industrial building framed with steel wide flange trusses supported by tube columns with a concrete roof. Before we get started with modeling, let's take a quick look at the SAP 2000 interface. All of the options are available through the top menu bar. Toolbars offer buttons that provide access to commonly used commands, including snaps, zooms, and views. An icon next to a menu command indicates that this item is also available as a one-click button. Typically, one defines materials and section properties, draws the physical objects, selects the objects, and assigns properties and loads to the objects. The model is then analyzed, followed by design if so desired. We start the process by clicking on File, New Model. Make sure that the default units are set to pound-feet. These are our default units, but any other units may be used while creating the model. SAP 2000 offers a wide range of parametric-based templates to help create your models, including 2D and 3D frames that could be used for our building. However, we will start by using only a grid definition. A thoughtfully planned grid system can result in enormous time savings, so spend some time at the start to make sure your grid captures the main geometrical features of your structure. Clicking on the grid button, we can now input the number of grid lines, followed by the spacing values. Note that by explicitly specifying the units, we can enter these values in units other than the defaults, and the program automatically handles the conversion. The grids appear in two view windows: an XY plan on the left and a 3D view on the right. The number of windows may be changed by using the controls in the top right corner. Next, we will adjust the height of one of the Z grids. Click the Define Coordinate Systems Grids command, and then the Modify Show System button. In the Z grid data area, enter 24 for the ordinate of the Z3 grid, and then click OK. We have shortened the upper grid spacing. Next, we will define the material properties to be used in the model. Click the Define Materials command. And note that two materials are predefined, one for concrete and one for steel. These are appropriate for the concrete roof deck and the wide flange sections, respectively. We will add a third material property for the steel tube columns. Click the Add New Material Quick button and select Steel from the Material Type drop-down list, and then ASTM A500 Grade B from the specification list. This is all we need to do to define a material when selecting from the predefined standards. Next, we will define the frame section needed for the column objects by clicking on the Define Frame Sections command, and then clicking on the Import New Property button. Verify that steel is showing in the property type list, and then click on the Tube button. Next, we will select and open the section database and select A500 Grade B46 from the material list. Clicking on the plus button allows editing of the material or additional materials to be added. Scroll down the list until you locate the HSS 8x8x38 section. Leaving the Frame Properties form open, we will next define the wide flange section properties needed for the trusses. Click the Import New Property button, and this time select the I Wide Flange button. Verify that the A992FY50 material is showing, and scroll down the list until you find the W8x10. Continue to scroll until you reach the W8x67 section, and select the entire group by holding down the Shift key and the left mouse button simultaneously. Now that these wide flange sections are available to the program, we are going to assign them to an auto-select sections list. This list will tell the program to choose from these sections when analyzing and designing the trusses. Name the list Truss and select all of the wide flanges. The program will use the median section as the starting section in the initial analysis. We can now assign the truss list just like we would an individual section. Make sure that the left view or XY plan view is active. You can make a view active by clicking anywhere in the window, and you can verify that it is active if the Display tab is highlighted. Next, click the View menu, Set 2D View command. Select the YZ plane option with X equal to 0 and click OK. This changes the view to a YZ elevation. Next, make sure that the Snap to Points option is on and click on the Draw Frame icon. We are going to draw the column objects and want the program to assign the HSS 8x8x38 sections to the objects. Start by clicking at the origin and then click again at the top of the grid to give a column 24 feet tall. Note that the position of the cursor is given in the lower right-hand corner. A right click will stop the drawing action, but leave you in the draw mode. We will repeat the process on the other side to draw another column. Right click and return to the Properties of Object form and select Truss from the Section drop-down list. This will assign the Truss Auto-Select list to the truss members we will now draw. We will start by drawing the bottom chord. Note that this chord is drawn as a single physical member. Repeat the process to draw the top chord, which will also be 36 feet long. Next, we will draw the diagonals. After drawing one half, click the right mouse button and continue by drawing the other half. Click the Set Select Mode button to leave the draw mode. Next, we will assign pinned releases to the internal truss members. select all of the internal diagonal and vertical members by holding down the mouse button and dragging the cursor across the objects right to left. As a general note, when in the selection mode, if you window from right to left, everything touched by the window will be selected. However, if you window from left to right, only items completely within the window will be selected. Click the Assign Frame Releases command and check the start and end boxes for the Moment 3.3 component. Click the Assign Clear Display of Assigns command to remove the pinned identifiers. Next, select the top chord by clicking on it and go to the Edit Lines, Divide Frames command to divide the single object into 2 frames. This will allow us to later alter the slope of the top chord. In this step, we will define the supports for the columns. We click on the 2 joints that define the bottom of the columns, and then go to the Assign Joint Restraints command. We are going to pin the column supports. Next, we will replicate the truss frame just drawn at other locations in our model. Click the Select All button to select all objects in the model. Click the Edit Replicate command and enter 12 into the DX edit box and 3 into the number edit box to replicate the frame at 3 locations at 12 feet on center. We will next change our view to an XZ planar view so that we can draw longitudinal beam members. We go to the Draw Frame command and select the W8x31 section from the section list. Our first member will be drawn along the top of the frame. We will add another frame object at the next grid level down. Leave the draw mode by clicking on the Set Select Mode button and select the 2 objects just drawn by clicking on them, remembering that they were drawn as single objects. This next step will tell the program to internally mesh these members so that they will be connected to all of the elements that frame into them. Next, we will replicate the beams just drawn at the other side of the building. Select the beams and go to the Edit Replicate command and set dx equal to 0, dy equal to 36, and the number equal to 1. Next, we will add the concrete roof deck into the model. Change the left window to an XY plan at Z equal to 24. And define the concrete deck by going to the Define Area Sections command. We will create a new section called Roof. Which will use the default 4000 psi concrete with a thickness set to 5 inches. Notice that by explicitly inputting the units, The program can automatically convert these to the base units of feet. Next, draw one of the deck panels by using the Draw Poly Area command. Make sure that the property is set to roof, and then click on the 4 corner points followed by the Enter key to define the first roof panel. Leave the draw mode and click the Set Display Options button. Check the Fill Objects box and the Apply to All Windows box. To make the model easier to see, we will turn off the grids in the 3D view. Next, we will mesh the roof panel to ensure connectivity with the supporting frame members. Right-click anywhere on the roof deck to display the Area Information form. Object assignments and loads may be edited directly from this form. Double-click in the Automatic Area Mesh Edit box and then select the Mesh Area Based on Points on Area Edges option. And check the intersections of straight line objects and the point objects checkbox. Next, we will replicate the roof panel to fill the entire roof area. Select the roof panel by left-clicking on it and note that the selection is shown in the lower left-hand corner. And then go to the Edit, Replicate command. On the Linear tab, type 12 into the DX Edit box and 2 into the number box. Now we select all 3 roof panels and will replicate to the other half of the roof. Next, we will move the roof objects to create the roof slope. We go to the Select, Specified Coordinate Range command, and click the At a Single Value option under the Y coordinate limits. With the operator set to equal, we enter 18 into the value edit box. In the Z coordinate limits area, again select the Add a Single Value option, but this time type 24 into the value edit box. This command will select all point objects that lie along the ridge line of the roof. We will move these selected points vertically 3 feet in the up direction. Note that the roof panels have moved up appropriately, but that the truss diagonals and verticals need adjustment. Returning to the specified coordinate range form, we select the Between Two Values option under the Y coordinate limits. For the first operator, we use the greater than or equal option and set the value to 12. For the second, we use the less than or equal operator and set the value to 24. For these selected joints, we will move them up 2 feet. For the last truss points, we use values of 6 and 30. These points will be moved up 1 foot. Next, we will modify the stiffness factors of the roof area objects so that they will not act as flanges for the top chords of the trusses. Selecting all the concrete roof panels by selecting their material property, we go to the Area Stiffness Modifiers command. And enter 0 into the membrane F22 modifier edit box. This prohibits in-plane axial loads. A check of the default load patterns shows that we have one pattern, dead load, with self-weight included. We will now add load patterns for live load and wind load. Now we will assign loads. Start by selecting the panel points along the bottom chord and go to the Assign, Joint Loads, Forces command. For the dead load pattern, we will apply joint loads of 20 kips in the down or -z direction. These are in addition to the self-weight of the structure. Repeat the selection process using the Get Previous Selection button and replicate the load at the other trusses. Next, we will apply a live load to the roof panels. Select the roof area objects by section property and go to the Assign, Area Loads, Uniform command. Here, we will input a uniform live load of 30 pounds per square foot in the gravity projected direction. Next, we will apply wind loads. Different loads will be applied in the windward and leeward sides of the roof. We will start with the windward load and select the roof area objects using the specified coordinate range command. We uncheck all the options except for area. The load will be applied as a surface pressure of 15 pounds per square foot to the top face. Now we will select the area objects on the other side of the roof and assign a surface pressure of -6 pounds per square foot. This results in an outward pressure on the leeward side. Next, we will select a design code and set up load combinations. We will use the AISC 360-05 design code for our steel members. For the combinations, we will let the program automatically generate our combos based on the selected AISC code. Clicking the Set Load Combination Data button, we will uncheck the deflection checkbox. For this model, we are concerned only with strength limit states. Note that 6 load combinations have now been generated. We can review these by selecting and clicking the Modify Show button. Note that the third combination is 1.2 dead plus live plus 1.6 wind, while the fourth is the same, but with wind applied with a negative factor. The model is now complete, and we are ready to analyze the model. Click on the Analyze Run Analysis command, and set the modal case to Do Not Run, as we wish to do a static analysis only. Click on the Run Now button. After the analysis is complete, the active window is updated with the deformed shape. Make sure that the left window is active, and click on the Display Show Forces command and select Frames. Here you can choose the load case and type of force to be displayed. A right mouse click on an individual member will bring up detailed force diagrams for that particular member. Next, click on the Display Show Deformed Shape command. Similar to the forces, a right mouse click on a joint will display the displacements for that particular location. We are now ready to start the design phase. Returning to the design menu, we will again select the View Revise Preferences command for steel frame design. Here we previously set the design code to AISC 360-05, but this form is also where other design parameters can be controlled. It is always a good idea to review these before starting a design. Next, go to Design, Steel Frame Design, and click on the Start Design of Structure command. After the design is complete, the design sections are displayed. If we window in, we can see that the program designed the bottom chords as single objects, even though for analysis they were meshed into smaller elements. A right mouse click on a design member will bring up stress check information, including the governing load combination. Note that the design section differs from the analysis section, so another analysis should be run, iterating until the two sections are the same. Clicking on the Details button brings up a calculation sheet with all of the pertinent design values. Having run the analysis and design several additional times, as a last step, one should check that the design and analysis sections match by clicking on the Verify Analysis versus Design Section command. One should also check that all members pass the stress check. This concludes this tutorial.